Okay, so we're reviewing for the test for Unit 4, and it's not only going to go over all the stuff we did in sections 1 through 6, but it's also going to go over area, perimeter, formulas of all of the different shapes. So you'll notice here that we've got formulas for well, first of all, these are the ones right here. Sum of the interior angles of a polygon, that is the one we learned in sections 4.2 and 4.3, but then perimeter of a parallelogram, perimeter of a rhombus or square, area formulas. These are all reviews from middle school math, and they incorporate this into this test as well. So let's go take a look at what some examples are going to look like. So what is the sum of the interior angles of a 16-sided polygon? So again, this is the one I just highlighted. We're going to be using the formula of 180 times n minus 2. Now, where did this come from? Remember that triangles have 180 degrees inside, and all of our polygons can be divided into the number of triangles, and that's going to be based on the number of sides minus 2. So if it's a 16-sided polygon, or if n is equal to 16, we're going to be plugging in 16 to subtract 2. So here we go, 16 minus 2 times 180. Grab your calculator, I'm grabbing mine, and do 180 times 14. How'd you do? Did you get 2520? Now over here they are talking about the exterior angles. So this is a different formula. Remember that the exterior of any polygon is equal to 360. So if we're trying to find the measure of one side, it was 360 divided by the number of sides. But in this case, they're giving us that angle measure. So they're telling us that it's equal to 17.14. But we know that the formula is 360 divided by the number of sides, and it's asking for how many sides. So we're going to take this and work backwards to find that n. So first we're going to multiply by the n to bring it up to the top. So we get 17.14n equals 360. And then divide both sides by that 17.14. And let's see our number of sides. So grab your calculator, see what you get. And I'm getting that this is a 21-sided figure. How'd you do? What is the perimeter of the rectangle given below? So if this is a 12, then this is a 12. If this is a 19, then this is a 19. And the perimeter is adding that all up. Or 2 times the side length of 12 and 2 times the side length of 19. So grab your calculators and do that for me. And I'm getting 62. And because they told us it was in centimeters, our perimeter is in centimeters. Number 4 says, what is the area? We know that the area is equal to the length times width. So grab your calculator and do 12 times 7. And hopefully you got 84. Now the units on this one are centimeters squared. Remember that area is square units. Perimeter is just units, and volume is cubic units. Okay, in the rectangle below, what is x? Now, let's think about a couple things we need to remember about a rectangle. The diagonals of a rectangle are congruent. So that means that this is equal to this. Well, the diagonals are also bisected, so that means that this is also equal to this. And when we have two sides are the same, we know that this is an isosceles triangle inside of that rectangle. And so since those two sides are the same, we know that these angles are the same, so we know that this is also a 33. So now I can set up my equation saying x plus 33 equals 180. or x plus 66 is equal to 180. So grab your calculators and subtract 66 and see what you get. And I got 114. How'd you do? All right, in this next one, what is x? So a couple ways you can do this, but when I look at this, again, I see that 41 and that 41 over here, but we're wanting to talk about this triangle on this side. Now remember that this entire corner of a rectangle is equal to 90. So couldn't we do 90 minus 41 to find that missing other angle, that complementary angle? So 90 minus 41 is 49. And so that means that this guy over here is 49. And this guy over here is also 49 because, again, we have this idea of the isosceles triangles inside of the rectangle. And that's all because this tells us up here that this is a rectangle. Okay, so here we go. X plus 49 plus 49 equals 180. X plus 98 and grab your calculator and do 180 minus 98 and you should get 82. How'd you do? Next is the area of a parallelogram. So just real quick, of course you can look it up, but way up here, area of a parallelogram is base times height. Base times height. So base times height is 19 times 15. Grab your calculator, see what you get. Did you get the 285? And since this is an area, we would say units squared. Again, if we don't have units, we have to still list units when we're doing geometry. We can say square units or units squared, whatever you're comfortable with. The parallelogram has an area of 115 and a base length of 12. What is the height? So this one's having us work backwards using the same formula. This time they told us the area. So outside here, we know that this is 115. And then they told us that the base length is 12. So we've got a 12 right here, and then an h is our unknown. So we're going to solve by dividing both sides by 12 to find that missing height. Grab your calculators. And I've got 9.58. And since we're rounding, we're going to put the approximation symbol in. And let's go look. Did they tell us square units? So 9.58 units. They didn't tell us if it was inches or centimeters or whatever. And see how right here it says to the nearest hundredth? And so that's why we went to 2 decimal places. All right, what's the value of x in the parallelogram? So again, before we get started, we're thinking of all those properties of parallelograms, and we know that opposite angles are congruent. So do you see the equation we should set up? Good. 2x plus 16 is equal to 104. Those opposite angles are congruent. So grab that calculator, do 104 minus 16, and divide that by 2. How'd you do? right, over here we've got consecutive angles. And we know that consecutive angles are supplementary. So this time we're going to go 4x minus 20 plus 61 equals 180. Now do 61 minus 20. Good, I hope you got 41. And then subtract the 41 from both sides. I hope you got 139. And then divide that by 4. How'd you do? All right, the next one tells us that this is an isosceles trapezoid. And the rule that we know about an isosceles trapezoid is that the base angles are congruent. So picture that this 82 equals the 5x minus 40. So taking that 82 plus 40, we got the 122 divided by 5. I'm getting 24.4. How'd you do? All right, what's the value of x on this next one? Okay, remember that opposite angles are supplementary. So these two are opposite in a parallelogram, are equal, but are opposite in an isosceles trapezoid are supplementary. So that means that 101 plus 2x plus 6 equals 180. So do 180 minus 107, and then divide that by 2. I got 36.5. How'd you do? Next, it's saying if a trapezoid has a base length of 18 and 40, what's the length of the median? So let's draw it out. So 18 and 40, what's the length of the median? We know that the median is equal to half of the sum of the bases. So half of 18 plus 40 is half of 58. Go ahead and grab your calculator and divide 58 by 2. And I hope you got 29. How'd you do? What's the area of the trapezoid below? So again, this is bringing back up your middle school math, just getting it all in there. So go back up if you forgot it, and notice that right here, area of a trapezoid is half of the sum of the bases times the height. Half of the sum of the bases times the height. So our height is 10. Sum of the bases is 7 plus 19. And technically half of 10 we could already say is 5. And then do this in a calculator if you need to. What's 7 plus 19? Okay, good. I hope you got that. Times 5. And remember in all of these that when we're doing the area, it is in square units or units squared when you're done for area. All right, now we're talking about rhombi. What is the area of the rhombus below? And they told us that AD is equal to 14 and BC is equal to 22. So real quick, let's look up here at our formulas. Area of a rhombus. I honestly don't know if you learned this formula this way back in middle school when you did this. But the area of a rhombus is half of its diagonals multiplied. Do you see that? Diagonal 1 times diagonal 2. So this kind of might be something new for you. Didn't even know that it existed. So the area of the rhombus is half of diagonal 1 times diagonal 2. So it's half of 14 times 22. So grab a calculator and do that. And again, it's square units if they don't tell us what the units are, because it's area. What's the perimeter of the rhombus below? Because it's a rhombus, remember that all of its sides are equal, and so the perimeter of a rhombus is 4 times the side length. So this perimeter is just 36 units. What's the value of x in the rhombus below? Remember that we need to remember that the diagonals are perpendicular to each other. So that makes this inner one 90. So when we're doing a rhombus and we know that that middle one is a 90, we can now set up this equation. X plus 40 plus 3x plus 90 equals 180. And go ahead and grab your calculators and finish this off. Double check those numbers. Now notice it's asking for the value of x. It's not asking for an angle measure, so we're done. Okay, same thing over here. It's asking for x. So now we can set up the equation because we know that that inside angle is 90. So grab a calculator. You're going to add 26 to 90. And then subtract 116 from both sides. And then finally divide by 3. And I'm getting 21.33 or 21 1/3. So we use the approximation symbol here. I'm going to write it down here below these words. X is equal to 21 1/3, or x is approximately 21.33 when we round. And that's the end of our review. I hope you feel ready.